All right, welcome. So today I want to do a quick refresher on simplifying radicals or simplifying square roots. Basically, we're going to be doing a lot with square roots over the next couple weeks. And so I want everyone to sort of have a quick refresher on how to switch between square roots of large numbers and the more simplified versions, just in case it comes up in some of the questions that we're doing. So for right now, we already know that when we see this symbol, that means square root. This, if you didn't know, is what we mean by a radical. So whatever number is under the radical, that's the number you're taking the square root of. And we know a lot of numbers have square roots that go to whole numbers. So for example, square root of 4 equals 2, and square root of 9 equals 3, so on and so forth. However, a lot of times we run into numbers that do not have square roots. So for example, a number like 20. We need to be able to simplify this to express it in terms of smaller numbers. So to do that, we're going to use what we call a factor tree. Right? We're going to break down the number 20 into other smaller numbers that will multiply to 20. And if we're doing this the most efficient way possible, we're going to think of numbers that square root that multiply into 20. So for example, I know that 20 is the same as 4 times 5. I also know that if I take the square root of 4, it simplifies to 2. And finally, if I take the square root of 5, it will not simplify, right? Because 5 does not have a square root. So if I want to simplify the square root of 20, and I know that 20 is the same as the square root of 4 times the square root of 5, then the simplified version is 2 times the square root of 5. And we can do that with pretty much any number as long as that number divides by something that has a square root. So another example would be the square root of 50. Again, I need to think of things that have square roots that can multiply to make 50. So I know 25 times 2 is equal to 50. I know that if I square root 25, it comes out to 5. And I know that 2 does not have a square root. So I know that the square root of 50 is the same as 5 times the square root of 2. All right, let's look at one more just in case. Let's take 48. Again, I cannot take the square root of 48. And so if I'm going through my numbers to try to divide this by, I know that 16 will divide by 48, or divide into 48 rather, give me 3, so 16 times 3. Square root both of my numbers. Again, it will simplify as long as at least one of these has a square root. There we go. So what if I had done that another way? What if I had instead said, oh, I can't remember if 16 divides in, but I know for sure that 48 is 12 times 4. And then I take some square roots. Well, 4 would square root to 2. 12 does not have a square root. Can I break down the 12? And I can, right? I know that 4 times 3 is equal to 12. And I can do the same process I did a minute ago with the 48. So let's see, what was I left over with? Well, the original 4 turned into a 2. The new 4 turned into a 2. And then, of course, the 3 did not square root. So if I'm trying to simplify, it's 2 times 2 times the square root of 3. And, of course, I know that 2 times 2 equals 4, which you notice is the same thing I got when I took out the 16. So in the end, as long as you're breaking down your numbers correctly and you're always looking for your square roots, you should wind up with the right answer. Sometimes it just may take us slightly longer to get to. Alright, and that's all I have for this video. I will see you next time.